Hello friends, welcome back my YouTube channel. I'm Maths. In this video, I will discuss the topic of group theory, which is permutation, cycles and order of length symmetric groups. So our main concept will be on symmetric group. This is very important group, and in the previous videos that we have already discussed about the group theory. In that video we have discussed about order of group, cyclic group, abelian group, and now we are going to discuss about symmetric groups. Before that, we should have an idea about permutations and what are the permutations, what are the permutation sets. In the basics of group theory, I discussed the permutation set that is denoting by Sn. Okay, so it may be n is equals to 1 2 3, okay, up to n. And now I will discuss the permutation group. It means if you have any set Sn, then when this will be a group and what are the properties of the groups in this that we are discussing here. And also we'll discuss the order of this group, and then we'll discuss length of cycle and some properties related to this symmetric groups. Okay, let's start the video. So now, first of all, we'll discuss what are the permutations here, what is the meaning of permutation. So by the definition of permutation, it is nothing but permutation of a finite set. Okay, if you have any set x is equals to 1 to n, okay, this is a set which containing natural number kind of thing up to n, only up to n. So from 1 to n is a bijective function, okay, that I have discussed already in the basics of group theory, which is available in playlist of the group theory. Okay, so how this set is formed? This set formed using some bijection, like it is basically bijective function. What is the meaning of bijective function? Means this function is 1 1 as well as this function is onto function. So this mapping is bijective function. Okay, so from where to where? From x to x. From x to x. If you have any function from x to x, which is something called 1 1 and onto mapping, and we can say onto mapping. If it is 1 1 and onto mapping, then we will say it is a like permutation. For example, if you have x 1 2 3, then function from 1 to 2, okay, from 2 to 3 and 3 to 1. Let's say it is what my x and it is x. So there are three elements are there. So 1 2 3, here 1 2 and 3. So now first of all, how can I map this function? 1 1 onto means here it is what 1 goes to 2, okay, then 2 goes to 3, okay, then 3 goes to 1. So it is what 1 1 and onto. So this mapping from here to here is denoting by sigma, and this mapping is 1 1 and onto mapping. Simply we can say this is a bijective mapping or bijective function. Okay, and this is like there is one more way to write this thing. If you have any element, like how many elements are there? 3. Write all the elements in this cycle form. Okay, now 1 goes to 2. What is the image of 1? That is 2. What is the image of 2? That is 3. Okay, and what is the image of 3? That is 1. Okay, now you can write in the cycle form. Okay, now you can write in the cycle form where start from 1. 1 goes to 2, 2 goes to 3, and now 3 goes to 1, means cycle get closed. So this is a proper way to define a permutation. So this is what the permutation from where x to x, a function which is a bijective function. Okay, now there may be different kind of ways to, like if 1 goes to 3, then 1 or 2 goes to 2 and 3 goes to 1, then one more cycle, one more element will be there for that set. So the collection of all these kind of we can say notations, or the collection of all these kind of elements. So what are the elements of this set? So these kind of elements will be in the set. So one two-line notation that I explained you, if you have any mapping like this, then we can also define in this form. What is the cycle notation? Just write in this form. Start every time, start from 1. So 1 goes to 2, 2 goes to 3, 3 goes to 1, it means it get closed here. Okay, so instead of writing here, simply we can write, if you are writing here, instead of writing instead of writing 2 rows, we can write in a single row, that is known as cycle notation here. Okay, sigma can be written like this. The meaning is same. Now one more example we can take. If you have, let's say, x is equals to 1 2 3 4 and 5. So this is the mapping from where 1 goes to 2. Now if I want to write here 1, start from 1 only, 1 goes to 2, 2 goes to 1 means this will get closed. Now again 3 goes to 4, 4 goes to 3, it will closed, and 5 is a lone element. So these are the cycle notation. Okay, so this is what the elements of permutation. Now if you have any element in this form, then we will represent in in the form of this notation of 2-line notation. Now we have one more thing using this. This is a set which is something called as group. Means this set will satisfy if it is a set or which is a collection of. Okay, so this is nothing but a set which is a basically the collection of all permutation. So this is nothing but the collection of all permutations. This will form a set, and this particular set is a group. So now when it will be group, it means it satisfies 4 properties. There exists a closure law. If I will whatever, it is under multiplication, or the multiplication is something which is related to the, okay, the multiplication is also related to here. That is what we can say about permutation multiplication. Okay, so now this is all about this. Our closure property will hold under permutation multiplication. Okay, then next property is something related to, we can say that associative property. If you are going to multiply, then associative property will hold. Identity will exist for this particular permutation if I will multiply. Okay, if I will, let's say sigma is any permutation here, if I will multiply with one another let's say permutation, that is identity, then I will get sigma again, that is known as identity permutation, that we will see here. So if it's this set and inverse is also there, if sigma is there, then sigma inverse is also there, so I will get identity. Now these all things that we are going to discuss here means it forms a group. There exist all these things that we will see here. So first of all, from here we can see what is the symmetric symmetric group. This particular group which is formed with these permutations is called a symmetric group. Okay, the set of all permutation x 1 to n form a group under composition of function. And which composition? This is nothing but a permutation multiplication that we will see here. Okay, this group is called symmetric group on n, and elements are denoted by Sn. So the notation of this group is denoted by Sn. This is something called symmetric group. Okay, and what is the order of this group? Order means number of elements of group Sn is equals to n factorial. Okay, and this is something, but how can we define this group? If you have any sigma, then a bisective mapping, sigma is called bisective mapping, then this will form a set. Now we may have different kinds of sets, let's say S1, S2, S3. So we can form S1, S2, S3 in such a way that I will show you how we can form all of these. So let's take one example. Start from S1. So S1 means, what is the definition of S1? Sigma from where 1 to 1. Okay, so from where 1 to 1, this is 1 to 1, and where my sigma is bijective. Sigma is bijective mapping. So now from here I will directly just write simply what can I do here? Yeah. From here I can simply write this is your let's say this is x and this is also x. So if it is x and here it is x, so one element is there, only one element. So this is this S1 will contain only one element, that is this. Simple, from 1 to 1. Next, if I want to write what is S2 here, so I will write simply S2. What is the definition of S2? Sigma is a mapping from where 1 to 2 and 2 itself, where sigma is bisective. Sigma is bisective here. Okay, I will write sigma is bisective here. Simply I will have here two elements in x, that is 1 and 2. Here it is itself x and 1 and 2. Now what are the possibilities I can make here? So first thing, I will write this element simply like this. Means this is what 1 goes to 1 and 2 goes to. Okay, this is the element. It is something called identity. This is also identity. Okay, this is the element which is called identity. Now next, what can I do? From here I can directly write, okay, from here I can directly write, if you have any element like this, then this is 1 goes to, from here I can write 1 goes to 2, 2 goes to 1. It means that simply I will write just 1 goes to 2. From here 1 goes to 2 and 2 goes to, there are two elements. So you can see here what is the set, what is set S2, that is simply identity. I will write identity and 1 comma or not comma 1 and 2. This is the cycle representation. So there are two elements in this set. Okay, now if I want to write what is S3, what is S3 here, so I will just simply write S3. Okay, so sigma is something from 1 comma 2 comma 3, and bisective mapping from 1 comma 2 comma, where sigma is bisective mapping. Okay, now what can I do here? Simply from here I will just write 1 2 3, and here again 1 2 3. Okay, so first mapping, simply 1 goes to 1, 2 goes to 2, 3 goes to 3. From here it is 1 2 and 3 is identity. Now from here I can simply write like this. So if I will write like this, I will write like this, or what are the possibilities here that I want to find here. So next I can write 1 goes to 2, 2 goes to 1, but 3 goes to 3, that is something 1 comma 2, and or 1 goes to 2 and is 3. Okay, next simply I can write here, that is what, so the next possibility is something like this. 1 goes to, from here I will write 1 goes to 3, okay, and 2 goes to 2, 3 goes to 3. From here I can write 1 goes to 3 and 2 goes to 2. Next possibility is, what is the next possibility that we can see here? So that is something, from here I will remove this. Next possibility is something like this. From here 2 goes to 3, 3 goes to 2, 1 goes to 1. So here it is what, 1 goes to 1, 2 goes to, sorry, 2 goes to 3 and 3 goes to 2. That's the simple possibility. Now what are the next properties or the next possibilities that we may find from here? That is something you can write here also. So next 1 1, okay, every time you keep in your mind you have to write 1 1 function. Next 1 goes to 3, 3 like 2 goes to 1 and 3 goes to 2. It's simple, what, 1 goes to 3, 3 goes to, okay. And what is the next possibility that we may find from here? Yes, what is the, copy this. From here I may write like this. So this is something, I will change possibilities. Then if 1 goes to 2, okay, 2 goes to 3, 3 goes to 1. So 1 goes to 2, 2 goes to 3, 3 goes to 1. That's the simple possibilities are here. Other than this, there is no possibilities. Now we'll say what are the elements of S3. Sorry, yeah, S3. Then element of S3 is identity. Element of S3 is 1, 2 and 3. One thing is that if you have any notation like this in which a single element occurs, no need to write that single element. That is by default. Okay, that is by default. So just write this cycle only. Here just write 1 and 3. Here just write 2 and 3, not comma, 2 and 3. Okay, here just write 1, 2, 3 and 1, 3. How many elements are there? 6 elements. Simply, what is the order of this group? From here, order of S1 is equals to 1. This is, which is nothing but 1 factorial. What is order of S2? That is nothing but 2, means 2 factorial. So from here, if I will write what is order of S3, that is 6, means 3 factorial. So simply, what is the notation here? Note point, order of Sn is nothing but n factorial. That's very, very important. Okay, this is, wait, yes, this is very, very, this is very, very important. Yeah. Next we have length of cycle. What do you mean by length of cycle? Okay, these are the formation of sets. How can we find the sets? Next we'll see properties. So now first property is length of cycle. What is the length of cycle? How can we find the length of cycle? You know, the cycle means is that if you have any two notation permutation, then we can write in the form of cycle. This is called a cycle. How many elements are there in one cycle? That is known as length of cycle. The number of element in cycles is called length of cycle. If R is the length of cycle, then we will say it is a R cycle permutation. So it is what? 3 cycle permutation. So what is the length of this? So simply we can see from here. So what is the, wait. So from here we can simply say what is the length of permutation? That is 3. What is the length of not permutation, length of this cycle is 3. From here, if I will say what is the length of cycle, so length of cycle is 2 only. For this is 2, for this is 1. Length of, because we are considering only simple thing. Next, what is the disjoint cycle? What do you mean by disjoint cycle? Disjoint cycle means two cycles are disjoints if they don't have any common element. For example, I have 1, 2, 3 and 4, 5, 6. Okay, 5, 6, 7. If I have a two cycle, this is sigma 1 and this is sigma 2. These are two disjoint cycles. There is no common element in this set. Okay, next, what do you mean by transposition? So that is very, very important. Transposition is something, a cycle of length 2. Okay, a cycle of length 2. So every permutation, yes, wait, the notations. So transposition means that, what do you mean by transposition? So it is nothing but every cycle, wait, is something, every cycle of length 2, that is known as transposition. For example, yeah, one thing is that any cycle can be expressed in terms of like can be expressed as a product of a disjoint cycle and can be expressed in terms of transposition. Now what is the meaning of this? If you have any cycle, for example, 1, 2, 3, 4, this is my cycle of length 4. What is the length of this cycle? Let's say it is sigma 1 and cycle is 4. So if it is a length 4 cycle, and if any cycle you have or any permutation cycle you have, you can express this cycle in terms of transposition. Now what is the meaning of transposition? Transposition is something called as whose length, a cycle whose length is 2. So I can write this cycle in terms of product of transpositions. What is that? So 1, 2, 3, 4 can be written in terms of 1, 2. So from here just write 1, 2, then 1, 3 and then write 1, 4. This is 1, 2, 1, 3 and 1, 4. Now we'll say, sir, is it really like it's equals to the product of this? Yes. When we will understand how to product two permutation, then I will show you how can these are equal. This is very important that you can easily prove. I'll show you how to multiply the transpositions also. Okay, so any kind of cycle, any length, if you have any permutation that we can represent or that we can express in terms of transpositions. Now one more observation is there. If you have any let's say if you have any transposition of length r, okay, if you have any transposition of length r, then how many numbers of that we can easily find the number of transposition. Let's say if you have next permutation is something 1, 3, 4, 5, okay, and 2. So it can be also, it is something this only. I can also express in terms of 1 comma 3, 1 sorry 1 4 and 1 5. It is what is the length of this? Length is 4. Here it is length 4. Let's say length is 5. If it is length 5, then 1 3 sorry 1 2 1 3 1 4 1 5. Here it is 1 5. So now simply from here can we say that is it really depending on the length of cycle that how many numbers of permutations are there? Yes, if you have any permutation of length r, if your permutation length is r, then number of transposition corresponding to that permutation is equals to r minus 1. Simply this is what length 4. How many transpositions are there? 3 transpositions are. Length is 5, 4 transpositions are there. These are very simple and very useful results are there. Now the thing is that how will you multiply, or what is the product of transposition? That is very important. So if you have any two, let's say sigma 1 and sigma 2 are two transpositions. Okay, so from here I will just write sigma 1 and sigma 2 are two transpositions. Okay. So if I have sigma 1 and sigma 2 are two transpositions, then I want to multiply this one. How will I multiply? So just write here 1 2 3 and 4, 2 3 4 and 1, 1 2 3 4, 3 4 2 1. What is the way to multiply this? So if you want to multiply, just count the elements. 4 elements are there, 4 elements are there. What is the minimum? That is 1. What is the maximum? That is 4. Just write the counting from 1 2 3 4. Means from minimum to maximum, write the counting. Okay, now start from here only. 4 goes to 1. Just see, 4 goes to 1, and here 1 goes to 2. It means 4 goes to, simply 4 goes to 1, 1 goes to 2. It means 4 goes to 2. That's the simple way. Next, 3 goes to 2. Now here 2 goes to 3. So 3 goes to 2. 2 goes to 3. So 3 goes to 3. 4 here 2 goes to 4. 4 goes to here. In this 4 goes to 1. So from here I can write what 2 goes to 1. Then next 1 goes to 3. 1 goes to 3. 3 goes to 4. It means 1 goes to 4. From here can I write in the form of cycle? Yes, I can easily write in the form of cycle. 1 goes to 4. 4 goes to 2. 2 goes to 1 means this closed. Here it is what 3. So simply what is this cycle? If you have given only that if simple way, the sigma 1 can be given in this form also. 1 goes to 2, 2 goes to 3, 3 goes to 4. This is your sigma 1. And if you want to write sigma 2, that is what 1 goes to 3, 3 goes to 2, 2 goes to 4. So this is something like this. Sigma 1, sigma 2 is nothing but 1 2 3 4 and 1 3 2 4, and the multiplication is equals to 1 4 2 and 3, or this is equals to 1 4 2. If you will not write 3, it is not necessary. Okay, so this is the multiplication. Now I told you that if you have any permutation like this 1 2 3 4, and we can express in terms of transposition 1 2, 1 2 1 3 and 1 4. Now if you will multiply this 1 2, what is the meaning of 1 2? 1 2 3 4, 1 goes to 2, 2 goes to 1 and 3 4. What is the meaning of 1 3? 1 2 3 4, 1 goes to 3, 3 goes to 1, otherwise 2 goes to 2, 4 goes to 4. Next 1 2 3 4, 4 goes to 1, 1 goes to 4, 2 goes to 2 and 3 goes to 2. Now if you will multiply, then you will get this also. This is very simple. Okay, what is the meaning of this? That's very simple. 1 goes to 2, 2 goes to 3, 3 goes to 4, 4 goes to. Okay, so these are the very like simple observations from here. Now if sigma, now some results are there. If sigma a1 a2 a3 up to ar belonging from SR, then order of sigma is equal to r. Order of sigma is equals to length. A simple criteria. It's the length. Now if you have two elements like sigma and gamma, okay, two permutations, so the length is r for this, and for this length is s. Then what is the length of the multiplication? What is the length of the multiplication? That is simple LCM of order of this sigma and order of this s. That's the simple observation from here that we can observe. Okay, if you have sigma, and what is the inverse? Now if I have any sigma 1, let's say 1 4 2 4 3 and 5. Now what is the inverse of this? If it means what? Simply 1 2 3 4 5. What is the meaning? 1 goes to 2, 2 goes to 4, 4 goes to 3, and here 3 goes to 5, 5 goes to 1. This is the notation of this this cycle permutation. What is the inverse of this? So sigma inverse is something, just write this line here and this line, means swap the rows in this particular matrix. So it is what? 2 4 5 3 1. Now just swapping means place should not change. Then here 1 2 3 4 5. Okay, can I write in the form of cycle? Yes, I can easily write 1 from okay. Now do one thing from here, just convert this in the standard form. Just convert this in the standard form. Now what is the standard form here? That's the simple. Convert every time 1 2 3 4 5, because it should be in the standard format. Okay, now how can we find? Just write 1 and this particular set 1 with 5. So what is the 1 goes to 5? Okay, 3 goes to okay, 2 goes to 1, here 3 goes to 4, okay, 5 goes to, here it is, means we have swapped the column only. Just write in this order 1 2 3 4 5 6, 1 2 3 4 5. Okay, then 4 goes to 2, and then 5 goes to 3. Then can you write in the cycle form? Yes, easily. 1 goes to 5. From here it is what? 1 goes to 5, 5 goes to what? Okay, simply we can write 1 goes to 5, 5 goes to 2, 2 goes to, here 2 goes to wait 1 goes to 5, and there is 1 goes to 5, and then 5 goes to 3. Yes, sorry. And then 3 goes to 4. Yes, 4 goes to 2, and 2 goes to. Now just see, it is something 1 2 1 2 4 3 5. This is your sigma 1. What is your sigma 1 inverse? That is 1 5. Okay, 1 5. Here it is 1 5 3 4 2. It is simply, if you will write like this, it is nothing but 5 3 4 2 1. Okay, we can easily write. So just if you have a1 a2 a3 a5, then just write in this way s. Okay, from here s minus 1, then 3 1. If you will write what is the inverse of this, inverse is simply 5 3 4 2, and that's the simple criteria. Okay, so this is all about inverse. And what if now, yeah, one thing is here also. If you are multiplying sigma, that is what? Sigma 1 sigma 2 sigma 3 sigma s. What is the inverse of this sigma? That is sigma s inverse. Just try to multiply like this: sigma s inverse, sigma s minus inverse. Okay, these are the inverse. Okay, these are the multiplication, not common. These are the multiplication also, that you can also prove by example. Then order of, okay, and one thing is there. Yes, if inverses are this, then what is the order of this? LCM of all these, whatever the order of sigma 1 sigma 2, that you can take the LCM and you will get it. Now one more thing that I want to explain you. This was the inverse. Now how will you find sigma in square, sigma cube, sigma power 4? There is trick. Okay, that by multiplication you can find what is the sigma 1 inverse. That's very easy. Sigma 1 into sigma 1 you can easily find. But what's the trick that I will show you? Okay, if you have any of the permutation like this, for example, if it is like this, okay, wait, then it is 1 2 3 and 4. Okay, means what? 1 goes to 2, 2 goes to 3, 3 goes to 4. This is my sigma. I want to calculate sigma square. What is sigma square? Then skip 1. If you want to calculate sigma 1, then skip 1. Means what? 1 goes to 3. Okay, 1 goes to 3, then 2 goes to 1 till here. Okay, 1 goes to 3, wait, 2 goes to 4, sorry, 2 goes to 4, and then 3 goes to 1, right? 1 goes to 3. Skip 1. 1 goes to 3. 3 goes to 1. Close. 2 goes to 4. 4 goes to 2. 2 goes to 4. 4 goes to 2. This is the square of this sigma. Very simple. Now if you want to calculate cube, what is the cube? Okay, this is square. Now skip 2. From here, okay, wait, this, yeah, skip 2. 1 goes to 4. Okay, then 2 goes to, from here 2 goes to 1. Okay, then skip 2. 3 goes to 2. Okay, that you can write simply in this form. So it means if it is what, any of the cycle that is what, length r. Okay, if you have any cycle of length r, length 4, it means sigma power 4 is identity. And one more thing, it is identity. Sorry, it is not identity, this is identity. Okay, if you'll do if you'll write sigma 4 means what, skip 4, 1 goes to 1, 2 goes to 2, 3 goes to 3, 4 goes to 4. What is the meaning of identity? 1 goes to 1, 2 goes to 2, 3 goes to 3, 4 goes to 4. This is identity element. Okay, so this is all about the permutation and its algebra. Now come to symmetric group. S is a collection of all permutation of the set S is defined as a group under composition of function and denoted by Sn. What's the order? Order of this group is n factorial, that's written here. Okay, simply. Now we'll show different kinds of group. So first one that I discussed you. So first one is only containing identity. What is S2? That is identity and 1 and 2. Okay, what is S3, which is something like this, identity. Okay, this is something identity. Okay, 1 2 1 3 2 3 1 2 3 and 1 3. This is S3. What is S4? You can easily find. Now one more thing is there. S4, there are how many elements are there? What is the adder order? So it is 2 into 3 into 4. 24 elements are there. We can't write that element, but we can find what are the types of elements. So here it is what, single A type element. This is called A type element. This is called AB type element, and this is called ABC type element. There are types of elements. So in S, A type element will be there, AB type element will be there, ABC type element will in that S4 you will have A, B, C kind of element. Now how will you find there will be element of this, like this kind of elements or not, yes or no? Okay, so what about A, B, C, D, E element? There any element of this type or not? That is something known as cycle decomposition. One concept is there that is known as cycle decomposition, that I will explain you. What is cycle decomposition? So if you are writing 2, in how many forms you can decompose this 2? For example, 1 plus 1 and 2. There are 2 ways. 1 plus 1 means A, B. So simple A type of element will be there and AB type of element will be there. You can see this is A type of element, this is AB type of element. Next, 3. 1 plus 1 plus 1. This is representing actually identity. So A type of element will be there. 1 plus 2 means AB type of element will be there. 1 is simple. Okay, just see the highest. Then 3. So it means A, B, C type element. C type of element will be there. So A, B, C. Now you can see this is A, this is AB, this is ABC. If I want to calculate how many elements or how many types of elements for 4, the C. 1 plus 1 plus 1 plus 1 means A type of element. 1 plus, okay, simply here I will write 1 plus 2 means AB type of element. Here it is 2 plus 2 is something AB and CD type of element will be there. Then 1 plus 3, it means A, B, C type of element will be there. And then 4, it means A, B, C, D type of element will be. These are the types of elements. So for example, 5, you can write for 5 simply 1 plus 1 plus 1 plus 1. Okay, then 1 plus 1 plus 1 plus 2, then 1 plus, here it is what, 1 plus 3, then 1 plus 2 plus 2, 1 plus 4. Okay, and 5. One more thing is there, that is what, 2 plus 3. Yes, you can also write 2 plus 3 and then 5. So it means what? A type element, AB type element, ABC type element. From here AB, CD element. From here AB, okay, C, D type of element here. From here AB, C, D, E type of element will be there, and it is what, A, B, C, D type of elements will be. So what are the, how many number of elements are there? 120 elements. 5 factorial elements are there. Okay, 24 elements are there. 6 elements are there. 2 elements are there. These are the number of elements and how will you deal with the form of element. Okay, different forms of element. Now come to the number of orders. Okay, before going to this, we'll see the properties of group. Sn is a group of all permutation on n symbols, also known as n symbols. Order of Sn is n factorial, that we all know. The identity element in permutation is 1, which is fixed for all elements. Okay, and each element Sn is bisective, that we have seen here. One more thing is there, it is non-abelian group, means whatever the permutation you are taking, sigma 1 and sigma 2, if you will take the multiplication which is not equals to sigma 2 and sigma 1, this is very important. Sigma 1 into sigma 2 is not equals to sigma 2 into sigma 1. So it means it is a non-abelian group. It does not hold the commutative property. Abelian group, okay, n greater than of 3 only. S1 and S2 are abelian group. Now we'll say why. We'll say why. What is S1? Only identity. Only identity means single element abelian. This is what only. From here I will say identity and 1 2. If you will multiply identity 1 2, it is of course equals to 1 2 into identity. These both are abelian group only. This is very important. Sn is generated by transposition cycle. Can be. Next, Sn is also generated by adjacent transposition. This is something called adjacent. Means what? 1 2. Next start with 2. Next start with 3 4. Okay, that it can be generated. Every permutation can be uniquely expressed as product of disjoint cycle. Yes, that is the property of permutation. Any permutation can be expressed in terms of transposition, but not unique, that we have seen, because it is what, 1 2 1 3 1 4. It means simply 1 2 3 4. Now these are not disjoint because 1 is common in each and every cycle. Okay, now the order of permutation is at least common, like that is something least common multiple. So that is simple. What the order of permutation. Okay, so S4 is the smallest non-abelian group. Is a smallest non-abelian group isomorphic to dihedral D3. Okay, isomorphic to dihedral group, that is known as D3 group, that I will explain you. S4 containing normal Kleins 4 group. Normal Kleins 4 group means here S4 is related. S4 is an abelian group. Okay, so S4 is an abelian group. This is also and it is not abelian, we can say, but it contains the normal Kleins 4 group. Okay, it has a abelian subgroup that we will see in the next subgroup video. Okay, Sn acts naturally as the set 1 2 3. This is the permutation set. Okay, Sn is the largest finite acting faithfully on n symbols, means it is the largest finite group. Okay, on n symbols. Sn plays a fundamental role in let's say Galileo's theory, algebra and combinatorics. Because it is very important, because it's the combinations of numbers, so it plays a fundamental role in combinatorics. Okay, so these all are properties of Sn. Now I will show you how will you find the order of element, and how many element of order 2, how many element of order 3, how many possible elements of order are present in that Sn group. That is because that is very important. Now the concept, how many elements of order D, or simply we can say what are the possible order of elements. Now see simply. So from here we'll just see S3. Start with S2. What is the cycle decomposition? 1 plus 1 and 2. Take the LCM of 1 comma 1 and LCM of 2 is 1 is 2. Means this is something called as possible ordered element or possible order of element. Okay, possible order of element. In S3, 1 plus 1 plus 1 means order 1, 1 plus 2 means order 2, 3 means order 3. One order element will be there, two ordered element will be there, three order element will be there. In S4, 1 plus 1 plus 1. Okay, 1 plus 1 plus 2, 1 plus 3, 2 plus 2 and 4. So one order element will be there, two order element will be there, three order element will be there, two order element will be there, and four order element will be there. Okay, now one thing, how many elements will be there? That's very simple. So now we want to calculate how many element of order 1, how many element of order 2. Okay, that I will show with example of S3. So number of element of order 1. So this is the formula. What is the formula? Just write the order of S3 divide by this cycle decomposition. What? 1 power 3. Whatever the power here, just write the factorial of that. Is what? 3 factorial. 1 power 3, 1 into 3 factorial. That is one element of order 1. Now next, number of element of order 2. Order of S3 divided by 1 power 1. Whatever the power, write the factorial. 2 power 1. Whatever the power, write the factorial. Now solve this. 3 factorial upon 1 into 2, that is 3 element of order. Or order of element 1, that is identity only. 3 element of order, that is 1 2 2 3. Okay, 1 2 2 3 and 1 is 1 3. Next, many element of number of element of order 3. Okay, because these three are the possible order. These are what? Possible order of elements. So now here it is what? Order of S3 divided by 3 factorial. Like 3 power 1 and 1 factorial. That is what? 3 factorial upon 3. That is simply 2 into 3 divided by 3 means 2 elements. What are those elements? 1 2 3 and 1 3. These are 2 elements who have order 3. In this way you can find the order of element in symmetric. Now one more concept is there, alternating group. What is the meaning of alternating group? So alternating group is basically a group of transpositions. AN means it has always, it is something called even transposition group. The group of even transposition. This is a group of even transposition. What is the meaning of this even transposition? So first of all, what I will take one example. What about, okay, just see S3. It is what? 1 plus 1 plus 1. Okay, then 1 plus 2. This is 3. How many transpositions are there? This is only one element. this is 2 cycle element and this is 3 cycle element. Transposition, so A3 is only containing 1 and 1 plus 2. This will contain only this cycle whose LCM is even, and of course identity will be there, and 1 plus 1 plus 1. It means it has 4 element. Which one? Identity, 1 2 1 3 and 2 3. No, okay, why 1 comma, why 1 2 3 and 1 3 2 are not there? 1 2 3 and 1 3 2, these are the element of S3, but now it is not element of A3. Why? Because write that cycle transposition, 1 2 and 1 3. Okay, so from here, wait, I will write in cycle composition, then yes, it is also okay. Yes, this will also be here because it has, okay, one more thing is there, not like, don't take any like permutation here. Okay, S3 and A3 are equal. Okay, but the thing is S3 has order 6, but it has order n factorial by 2. Okay, these are not. So what are the elements are there? Wait, this one mistake is here. What are the elements here who has even permutation? Just see, identity 1 2 1 3, okay, 2 3 1 2 3 and 1 3 2. Now write the write in this like permutation form. This is what a single permutation means. It is not even permutation. This is a single permutation, not even permutation. This is single permutation, not even permutation. Identity will be there, this will not be there, but write this 1 2 3 1 3 2. Write in permutation form 1 2 1 3. Even permutation, yes, this will be the element of A3. Here it is 1 3 1 2. This is the element of this. Now what are the element of A3? Element of A3 is identity 1 2 3 and 1 3 2. So from here, order of an is something n factorial upon 2. So means order of A3 is what? 3 factorial upon 2 means 3. So now you can see 3 elements are. Similarly, A4. What is the A4 here? Just simply see. Just simply we can write here. Wait. Simply we can write here. I'll explain A4. What is the order of A4? That's 4 factorial divided by 2 means 6 elements are there. Okay, 6 elements are there. 20, not 6, wait, 12 elements. 24 divided by 2 means 12 elements are there. Okay, 2 into 3 into 4 divided by 2. Okay, so 12 elements are there. If 12 elements are there, what are the elements? Write S4. 1 plus 1 plus 1 plus 1, then 1 plus 1 plus 2, 1 plus 2 plus 1, that's the same thing. 2 plus 2, 1 plus 3. Next, from here, next 4 will be there. 2 has even permutation. It has even permutation. Okay, just take only even permutation only. So this is what this is something like A4 who has 12 elements are. It's very important. Okay, so what are the elements are there? That is what? 1 plus 1 plus 1 in A4. I'm talking about A4. Okay, and 2 plus 2 and 4, 1 plus 1 plus 2 also. So how many elements? So total 12 elements are there. Okay, now how to find the element of order? That is the same process in which we are finding in S3. What are the properties here? So properties there, it is also sub, and now here it is what? An is subgroup of Sn, that I will explain you in the next subgroup video. So An is also normal subgroup of index 2. An is a normal subgroup of order 2, that is index 2. It means it is an abelian kind of thing that I will explain you. Okay, in the subgroup form. An, if n is greater than equal sign, then An is a simple group. Simple group means who has only who has no non-trivial, means who has only 2 subgroup, that is the trivial, identity and itself. Okay, then generators, An can generate by, generated by 3 cycles. Okay, so these are some definitions are there. and here it is what plus minus is the sigma and the product of even transpositions, and minus 1 if the product of, okay, this is something called sigma, like signum of sigma, plus 1 and minus 1. Okay, we can define in this form. Okay, signum. Next. Okay, so this is all about AN and SN. So thanks for watching my video. Keep watching MS Maths, in which I have explained complete permutation, cyclic permutation, symmetric group, even symmetric group. Also I have explained AN, that is something, AN, that is called a group of even permutation. Okay, this is basically the part of. Thanks for watching my video. Keep watching MS Maths. Thank you. Bye bye. We'll meet in the next video. Take care. Thank you. Bye bye.